All right. Hi, everybody. My name is Sebastian Aigner. Thanks a lot for joining me today for my talk titled Kotlin.js today and tomorrow. It's awesome to have the opportunity to have everyone's attention this early in the day when everything is, when everyone's still eager to learn something new and everyone's still fresh. So I want to use this opportunity to spend the next 45-ish minutes talking about my favorite target for Kotlin, and that's JavaScript. Now, I hope that I'll be able to inspire you a bit, give you some insights that you might not have had before, and share some of the plans that the clever developers in the Kotlin.js team have. As I said before, I'm Sebastian. I work at JetBrains as a developer advocate, and I mainly focus around topics concerning Kotlin as well as Kotlin.js. And that's also kind of the reason why I'm so fired up to talk to all of you folks about something that I'm kind of perpetually excited about, how one of my favorite languages, Kotlin, works on one of the world's most prominent ecosystems, so JavaScript. So let's waste no time and get right into it. Because I think to understand the true potential of Kotlin.js, we need to know how it works, and especially how it works together with the things that already exist in the JavaScript world. Because the truth is, modern applications targeting JavaScript have come far from being just a simple script that gets embedded in a website. I'm talking tooling. There's bundlers that perform post-processing steps on your app. There's dependency managers like NPM or Yarn. And of course, there's a vast ecosystem of packages with over 1 million packages on NPM alone. Now, as Kotlin folks usually have most of our build and tooling configuration in one central point, which tends to be our Gradle config. And here's the great news with Kotlin.js, it doesn't have to be any different. Because through a tight integration with Gradle, we can actually manage our build dependencies and our packaging just like we would when targeting any other platform. And I really want to drive home the point that this elephant on the left here is our ally. Because thanks to the work of our developers, Gradle, together with the Kotlin.js plugin, provides a central point of configuration even for the most important JavaScript-specific topics. Now, whether it's some Webpack setting, an NPM dependency, or even trivial things like making sure that there's an available Yarn installation on your machine, the Gradle plugin can take care of all of that. Now, thankfully, most of this magic actually happens behind the scenes without us having to think about it. I find this especially comforting when maybe you're not yet best friends with that elephant in the top right corner, or you just want to limit the amount of Gradle configuration you have to write. In general, you can apply the JS plugin very similarly to the Kotlin Multiplatform plugin. And let's actually talk about that for a second. Because we believe that Kotlin Multiplatform and its code sharing approach can help make the most of Kotlin JavaScript as well. You may have already suspected this, but just to make it explicit, as one of the possible targets for Kotlin Multiplatform project, you can of course use all the mechanisms for code sharing in Kotlin.js that are available for other targets as well. So common code, expect actual, the usual suspects. It's also one of the reasons why the configuration language you use to set up a Kotlin.js project is completely compatible with the one you would use in a multi-platform project. Now, these compatible DSLs should give you peace of mind when it comes to setting up a project in the first place, because if you decide to add another platform to a project, you're starting with the JS plugin. It's as easy as switching it out for the multi-platform plugin and adding a new target. If you've already have some common code between JVM and native, for example, it's as easy as adding another target to your multi-platform project, at least from a Gradle configuration point of view. Now, as Kotlin developers, our Gradle configuration is also the central point where we define our dependencies. And there's no difference for Kotlin.js. Common Kotlin libraries and libraries that are made specifically for Kotlin.js can simply be included using their coordinates. And even JavaScript dependencies from NPM can be pulled in by declaring them in a very similar fashion. So in this example, I'm just downloading a single function package from NPM that converts arbitrary text to camel case, just by adding one line to my configuration. Now in the background, the Gradle plugin then takes care of downloading and making this NPM package accessible from within our project without us actually having to do anything extra. At this point, all that's left for us to do is to tell the statically typed Kotlin world about the types of the function we just imported. So in this case, an external function that takes a string and returns a string. And now we actually have a function that we can call from Kotlin.js code, and that resolves to native JavaScript code. And we are not done here, actually. The team is working actively on making this, well, currently 3-step process even smoother. But I'm getting a little bit ahead of myself. We'll see more about that later. Now, options to configure and adjust our project as we kind of expand and build on it are very important. But honestly, we believe that it's equally important to reduce friction when you're just starting out. Because at the end of the day, we want to provide you with same defaults and a good place to start off from. You may already know that in IntelliJ IDEA, there are the Gradle wizards, but going forward, we actually also have the new experimental project wizard, which comes with a lot more templates and allows you to customize your project before you even write your first lines of code. Now, if you're already feeling antsy getting started with this, you can actually find the new project wizard already in the milestone release for Kotlin 1.4. In the same vein, we want to provide first-class tooling support for the Kotlin.js target. This begins with supporting Gradle functionality like continuous build execution. What does that mean for Kotlin.js? Well, the Gradle plugin actually works together with a development server provided by Webpack. So by passing in a flag to the Gradle process, we can actually cut down on iteration times by rebuilding and reloading our project whenever we save some new changes. So in this example, I've started the application and the development server with the flag. And you can see that as soon as I change some text in my code, a recompilation is triggered and the page reloads and we see our changes. But tooling, of course, doesn't just mean build tools, it means IDE support as well. And just like other Kotlin targets, when you have a project that includes or even solely targets Kotlin.js, you can get an experience that's very similar to the other platforms. You can debug your code directly inside the IDE. You can see sensible stack traces, have IntelliJ IDEA manage your source sets, and more. Now, one central point that makes a lot of that possible is source maps. Source maps generally allow tools to map the compiled JavaScript files that are generated by Kotlin.js back to the original Kotlin source code, which helps immensely with debugging and avoids having to wade through meters upon meters of minified JavaScript code. Because let's face it, if you would be debugging a JVM application, you would also not look directly into JVM bytecode. And as you can see, this is not actually just limited to IntelliJ IDEA. If you want to investigate an issue using the browser developer tools, for example, you can do so, but you still have Kotlin code right in front of your eyes. Ideally, we want to catch issues earlier than in the browser debugger, though, which is why Kotlin.js provides integration with test runners for the JavaScript platform, like Karma, for example. And all important tasks around testing can actually be accessed without ever leaving IntelliJ IDEA. And again, thanks to the magic of source maps, even though they are run using a JS test framework, the stack traces will still point us to the erroneous parts of our application. If you're wondering how these test runners can be configured specifically again, the answer is once again a Gradle configuration. We really try to make it the central hub to configure the most important settings you would want to adjust in a project. Now, good tooling is a lovely goal to have, but I think we can all agree that it's only one piece of the puzzle. So for the next couple of minutes, I want to highlight some of the strengths that Kotlin.js has, in my opinion. I want to make it very explicit that I consider this list to be non-exhaustive, because honestly, I could probably talk for a few hours about all the things I enjoy about Kotlin.js. For now, you're going to have to make do with the selection I have here. You can, of course, catch me later, and I'll probably won't stop talking about the technology. You have been warned in advance. Now, the first thing that I enjoy every time I start a Kotlin.js project is knowing that I'm not alone. A lot of the libraries we build at JetBrains around concurrency or networking or testing make use of common abstractions. So they have artifacts available that I can simply put in my build file with a line or two, and I get to use them. Let's maybe have a look at some prominent ones. Now, at this point, I'd be really surprised if you didn't know about kotlinx-coroutines yet, so I'll even spare you a short-winded intro to the library. All you really need to know is that they work on JavaScript, and they actually have the potential to make your code targeting JS so much cleaner. Because the JavaScript world is kind of partially known for what's called callback hell, when you wrap every callback in another callback in another callback, and you end up with code that just slowly inches to the right side of your screen. And one of the strengths of coroutines actually fixes this issue, because they allow you to write code that looks sequential without giving up the power of concurrent execution. They're also a convenient way of preventing to have some set timeouts scattered across your application to schedule recurring tasks, for example. And by no means is coroutines JavaScript agnostic, by the way. The library provides wrapper functions to await JavaScript promises, for example. So we end up with nice linear code, even when using promise-based browser APIs, which, by the way, are all available in a type-safe manner from Kotlin code. One small side note, though, as some of you might know, JavaScript by default is single-threaded, and the introduction of coroutines, of course, doesn't change that. So that means that coroutines work wonderfully when you have a lot of IO-bound tasks occurring at the same time, but they don't magically fix the problem of being able to utilize more CPU cores for computation-intensive tasks. Now, a library that maybe a couple fewer people know is Ktor Clients. Now, Ktor is already pretty popular as a server-side framework to build APIs and connected applications in general. Now, what fewer people know is that for the Ktor server, there's also a counterpart on the client side. So whether you're trying to consume HTTP APIs or connect to a WebSocket, if you've worked with Ktor on the server before, you'll feel right at home with Ktor Clients as well. And truth be told, if you haven't worked with Ktor before, you'll probably still feel right at home. I mean, calling an API endpoint that returns a string in a single line seems like a graspable API. And of course, in true Kotlin fashion, Ktor clients also use coroutines, so they integrate nicely. Another library that I've come to appreciate a lot, and that's also not Kotlin.js exclusive, but certainly available for Kotlin.js, is kotlinx.serialization. It's the pure Kotlin answer to the question, how do I turn my Kotlin object into a representation that I can send over the network? Now, the fact that kotlinx.serialization is available for Kotlin.js is highly useful, because especially in the front end, we tend to consume a lot of APIs, and being able to serialize and deserialize responses and requests and communicate with remote APIs in a type-safe manner is actually quite convenient. And once again, I just quickly want to share some of my glee about the brevity with which all of this happens. Because after including kotlinx.serialization in the project, it's as easy as annotating a data class with a serializable annotation. And at that point, we can already turn our Kotlin object into a JSON string, for example, and a JSON string back into a Kotlin object. Now, the three fellas I talked about, coroutines, Ktor, and serialization, actually make a wonderful team. Because based on what we've just learned now, we can configure the Ktor client to use kotlinx.serialization. We can provide a Kotlin data class as a serializable model. And then finally, we can access our API in a type-safe fashion, starting from our request client. And of course, the fanciest part about all three of those topics is that they aren't Kotlin JS specific, they aren't Kotlin JVM specific, they are truly multi-platform, which means that the to-do data class you see here on the slide, it could serve as a common abstraction that could be used and serialized by a Ktor server in our project and deserialized by a Ktor client, all while maintaining type safety and avoiding any duplication in our model, or even having to rely on additional specification that's not written in Kotlin at all. This can be quite convenient, and honestly, the fact that I can fit all these concepts on one slide and the text stays a readable size is, in my eyes, just so amazing and another testament to Kotlin's conciseness. And the folks building kotlinx-coroutines continue to push the boundaries with functionality like multi-platform polymorphic serialization, which works especially well with sealed class hierarchies. Essentially, what it does, it allows you to transport objects that have different types, for example, through the same WebSocket, and properly reassign their type on the other side without having to have a stringly typed layer in your application. I personally think this is the most exciting feature of kotlinx-serialization, and if you've heard any of my user group talks, you already know that I like to squeeze in this topic every now and then. So if you want to hear me ramble on about that more, just ping me after the talk. Now, chances are, especially when you are working in an established project or team, that not your full front end of the application will be written in Kotlin.js. That's one of the reasons why we are paying increased attention to playing nice with code bases that already contain JavaScript or TypeScript code. For these situations, you'd ideally want to make your common abstraction, so for example, your business logic, available as a library in Kotlin that can then be consumed by front-end developers using frameworks like React, Vue, or Angular, for example. Now, to make this a smooth experience and to integrate well with all your tooling, including stuff like autocomplete, linting, and everything else, we are currently working on providing TypeScript definitions for Kotlin code. You can already check out the milestone blog posts for Kotlin 1.4, where you can find some instructions on how you can actually try this functionality already. Now, it is exclusive to the new IR compiler backend, which we'll talk about in just a second. But I truly believe that one of the big strengths where we'll see Kotlin.js in the near future is exactly this approach: to write parts of your business logic in Kotlin and then consume this business logic from JavaScript. And I guarantee that once this feature is out of preview, we will provide learning materials around how you can build exactly such libraries yourself. From a usage perspective, the mechanism behind this is rather straightforward. If you want to export a top-level definition like a class or a function to the JavaScript world, you simply add the corresponding JS export annotation to it. When compiling, the IR compiler then makes sure that these symbols can be accessed from TypeScript and JavaScript. And all your tooling, such as autocomplete engines, linters, and type checkers, will be able to use this information. Other declarations that are not marked with the JS export annotation won't be exported to the. Now, a few moments ago, so let's talk about that at least on a very high level. While it's currently still experimental, it's the clear path forward for Kotlin.js. And besides TypeScript definition, the team has a bunch of other features in store that I hope will actually convince you that it's going to be an exciting time once we can make the full switch to this new compiler backend. It's going to be the main focus of innovation around Kotlin.js and will also heavily improve on pain points that the previous compiler still had, like the size of the generated code, for example. Of course, we rely on your feedback, so if you want to try out the new experimental IR compiler already, check the milestone blog post for Kotlin 1.4, which include instructions on how to try it. We'll also see some of the planned features in the last part of this talk. Now, I've talked about improving the code size, and especially with an improved method of dead code elimination, we are planning to reduce drastically the size of the artifacts that are generated by Kotlin.js. Now, a Hello World example code can be reduced down to something like 1.7 kilobytes. These numbers are for a more complex demo that actually use kotlinx-coroutines. As you can see, the numbers have changed quite drastically and hopefully speak for themselves. Now, like I said, most existing code bases likely consist of some JavaScript or TypeScript already, and that's perfectly fine. It's not the intention of Kotlin.js to push out other technologies, but rather to empower you folks. But I still want to spend a few minutes to showcase what you can do with more or less pure Kotlin code when you decide to use it for front-end development, though. And I want to lead with something super simple. Now, check out this HTML code snippet. If you've worked with HTML before, your mind is probably coming up with the right idea of what this page would look like, something like this. But then you look closer and you see that there's actually an issue there that you probably wouldn't notice, maybe until you're scratching your head why your link isn't working. Well, at least for me, I'm somewhat spoiled by the good tooling and compiler support that exists around Kotlin. So it would be kind of awesome to have something similar around my markup as well. And well, the Kotlin library world actually has a neat answer for that, kotlinx-html. It's a Kotlin DSL, so a domain-specific language that allows you to write typesafe HTML. It's actually available for Kotlin.js and other platforms, and it's realized by using Kotlin functionality like creating lambdas with receivers, the usual. And as you can see, we end up with a very similar markup, but we have added safety. So the compiler will complain if we misspell the href attribute, for example. And since this code is just regular Kotlin code, we even get regular tooling support like autocomplete or refactorings from our IDE. And if that actually wasn't enough, there's actually another benefit. Because if this is just Kotlin code, then it means that we can have Kotlin constructs inside this code as well. So we can define lists, for example. We can iterate over them, and then kotlinx-html takes care of converting them into nodes for our document, which can then be displayed in the browser. And we can go even further. We actually provide type-safe Kotlin wrappers for the React framework as well. And thanks to their new hooks API for state management, I can actually fit a full reactive component in just a few lines of Kotlin code on this slide. In this case, it's just a button that counts up when you press it. Now, Kotlin React, once again, uses a typesafe HTML DSL to provide you a convenient abstraction for defining how your components render. Unfortunately, diving much deeper into Kotlin React would absolutely obliterate the scope of this talk, so I will move on. However, if this is a topic that interests you, then check out play.kotlinlang.org, where we have some long-form tutorials that walk you through writing React apps with Kotlin. And now that I think about it, they actually also cover a few of the topics we briefly glanced at beforehand, like using NPM dependencies directly from Gradle, for example. Now, the libraries and wrappers we've seen so far are actually all projects that are supported directly by JetBrains. But of course, there's an ever-growing number of libraries that target common Kotlin code, and as such can be used with Kotlin.js. And new libraries specifically for Kotlin.js are also sprouting up everywhere. Now, I want to take this opportunity to highlight some community efforts around Kotlin.js. Now, for obvious reasons, I can't talk about every project here, so I apologize if one of your favorite projects is not included. If you feel like your project should be highlighted, just shoot me an email and I'll take a look, and maybe we'll see it in one of the next presentations. The first one is Korge. It's a multi-platform game engine which allows you to write games in Kotlin and deploy them to a number of different targets. In fact, they are currently organizing a game jam. So if you want to broaden your horizon with an interesting multi-platform library, win some prizes, and maybe build the next big browser game with Kotlin.js, consider giving Korge a shot. The next community library that I want to highlight is Data2Viz, which I think is such an interesting effort because they essentially took the concepts behind D3.js, the popular data visualization library for JavaScript, and re-implemented the functionality in pure Kotlin. And what you get out of that is a data visualization library that is truly multi-platform, which includes Kotlin.js, and that has APIs that make use of the constructs that Kotlin has to offer, rather than just simply being a wrapper for an existing API. On the Play version of the website that you can see in the bottom right here, they actually have a bunch of cool examples of the visualizations and even a web editor which allows you to kind of modify the visualizations and try the library for yourself. And lastly, I want to give a small shout out to one of the new kids on the block, a framework for building reactive web apps in pure Kotlin.js called Fritz2. It's a new effort that's kind of inspired by some frameworks from the Scala world and heavily relies on coroutines and flow concepts to build reactive apps in pure Kotlin.js without relying on anything else. It's still kind of early in its implementation, but I think it's cool to kind of just see their development efforts. Now, I hope that I was able to whet your appetite a little bit with all these possibilities, but to inspire you a bit more, I wanted to spend a couple of minutes to talk about some instances at JetBrains where we use Kotlin.js, namely a toy project and a full product. So let's start with the toy project, one in fact that we built within 48 hours in a team of 5 people. And those of you who were at KotlinConf, you may actually recognize this project. It's called Code Quiz, and it's a multiplayer game that's aimed at helping people test their programming knowledge, and of course, specifically their Kotlin knowledge. The way it works is that a presenter with a big screen shows a code question, and the audience connected via web applications on their phone can lock in their answers and collect points. Now, Code Quiz is a Kotlin multi-platform project that uses a bunch of the technologies that we've also seen during the talk. It uses Ktor-powered WebSockets to communicate between a JS frontend and a JVM backend. All data models are shared using kotlinx-serialization. And since we are reusing the same WebSocket, it uses sealed class hierarchies and polymorphic serialization. So yeah, I just had to bring that up a second time. And again, that just ensures that our backend and frontend are always in sync in a type-safe manner. Interface, both for mobile and for the presenter view, is written in React with Kotlin and makes use of a few external components and libraries for animations and graphs, for example. Now, if you've ever participated in a hackathon yourself, you know that they're tough and hard work, and it's precisely why I believe that Kotlin.js and multi-platform were so instrumental for us. Firstly, most of us were Kotlin developers, so it was easy for people to jump between changing parts of the user interface and changing parts of the server-side quiz management and speak in terms that everyone understood. Because kotlinx-serialization provides us with type safety throughout our whole stack, we actually became a lot more confident in working on related pieces at the same time and on code as a whole. Because it's a lot less scary changing a class or even the messaging structure when you have a compiler looking over your shoulder, doing almost what are a form of integration tests across the two platforms. And after 48 hours of prototyping and iterating, we actually did have something we were quite proud of, and it did pay off. We won the entertainment category in our hackathon, and since then we've used Kotlin's Code Quiz a couple of times, most recently at KotlinConf, where attendants could come to our booth and win some prizes if they high scored on our quizzes. Anton Keks's talk on Kotlin Puzzlers, which is kind of known for its interactivity, was actually also held with Code Quiz at the latest KotlinConf. Now, I'm not implying that using Kotlin.js will bring you success, but it certainly helped us succeed in high-stress situations, and I'm positive that you could find a way where it could do something similar for you as well. And of course, the Kotlin.js and multi-platform journeys, they don't stop at hackathon projects. We're successfully using Kotlin.js inside JetBrains to build parts of our newest product, JetBrains Space. If you don't know what JetBrains Space is, it's our integrated team environment that unifies the whole development story. So from team organization, communication, and planning, all the way to sharing code, building, and delivering software. It's a complex system made up of many components, but one of the main ways you interact with it is through a frontend that's written with React and Kotlin.js. And of course, the Space team also makes heavy use of code sharing between different platforms, which in addition to JavaScript also include JVM on the backend, native on iOS, JVM on Android. There's actually a great talk by my colleague, Maxim Mazin, if you'd like to understand a bit more how Kotlin is used in a complex system like JetBrains Space. It's very aptly titled Kotlin in Space, and you can find it on YouTube from last year's Kotlin Conf. Well, looks like we got through a ton of content about what you can do with Kotlin.js right now. We've even seen that it goes as far as building full products with it. As I've kind of alluded to before a bit, there are some exciting topics that are still in the making, and I'm happy to share some of them. So first, let's talk a little bit about the automatic generation of external declarations for Kotlin. If you remember, when I showed the import of the Camelize NPM package at the very beginning of the presentation, I had to write an external declaration for the Camelize function. This works perfectly fine for smaller NPM packages, and there's certainly no shortage of single function NPM packages. But when you want to start using dependencies that have a richer API and still want to maintain type safety, instead of falling back to the dynamic type, it can become a bit cumbersome to write all of these external declarations manually. Now, thankfully, the JavaScript community has established a de facto standard for providing type definitions in the form of TypeScript declaration files. The Ducat tool, which is currently in development, aims to allow the automatic conversion of exactly these TypeScript declaration files into the Kotlin external declarations that we need. Now, had I used Ducat when importing the Camelize NPM package, then it would have auto-generated the required external function signature based on the type information that's already included in the package. You can actually already try out Ducat, even though it is still experimental. If it's something that interests you, I would suggest having a look at the repository. But then again, since it is still experimental, you can expect parts to break. Mapping one type system onto the other just is a non-trivial task. But it also makes it a great time to report early problems on the issue trackers. If you do that, the folks developing Ducat will know which issues have to be tackled first on the way to providing great support for a wide number of libraries. Now, as a side note, Ducat in its current form is actually already pretty powerful. In the current versions of Kotlin.js, the Typesafe browser APIs that are available, those are actually generated by Ducat from the web interface definition language. And another thing that's also powered by Ducat and that we're working on is providing type-safe Kotlin wrappers for the Node.js API. Now, unlike the browser standard library, which is currently shipped with each Kotlin version, the Node counterpart will be available as a separate artifact called kotlinx-Node.js. You can actually already target Node.js with Kotlin, but its real potential gets unfolded when you have type-safe access to the Node.js API and can easily interop with the file system, for example. There are also a bunch of features that will be made possible by the switch to the new, but currently still experimental, IR compiler backend. For example, compilation speed. I think nobody is going to argue with me when I say that tight feedback loops when developing something are a good thing. You can change something in your code and you probably want to see the results as soon as possible. While continuous builds that we've seen at the beginning of the talk already help tighten the feedback loop quite a bit, the new IR compiler will support true incremental compilation, which we hope will make it even easier to kind of see the effects of small changes in your application quickly. And we are, of course, also well aware of some of the pain points that folks are facing with the size of the generated JavaScript. We've already talked a little bit about dead code elimination beforehand, but the clever folks in the Kotlin.js team are also working on a first version of code splitting, which will split your project on a per module basis and generate custom artifacts for your projects, once again with the goal of reducing code size, improving load performance, especially in larger projects. Now, one feature that's currently still missing in the new IR backend is the support for source maps. We've seen before that they can play a significant part when it comes to hunting down issues, for example, using the browser tools. This is why the team is working hard on providing this exact feature in the new IR compiler soon. We also want to make it easier for developers of libraries to support users that are using the new compiler backend without having to drop compatibility with the old backend. For this, we have a special compilation mode, which we call both mode. It allows you to kind of generate artifacts that are compatible with the new IR compiler as well as the current compiler. And by making use of Gradle metadata, you can actually keep those artifacts at the same coordinates. So you won't have to start suffixing your packages with an IR tag or something. As long as you compile in both mode, your users can just include your artifacts and Gradle will figure out the rest for you. Another thing I personally can't wait to showcase in our learning materials is our upcoming support for ES6 modules. If you've worked with JavaScript for a while, you'll know that its module system was quite fragmented for a long time. And especially if you didn't have a lot of experience in the ecosystem, it was kind of hard trying to find the correct combination of spells to get everything working in order. Now, with ECMAScript 6, these topics have kind of cleaned up quite a bit. And Kotlin.js supporting ES6 modules in the near future is going to mean that any library you write using Kotlin.js, you will be able to consume from JavaScript in the same fashion as other modern libraries. Of course, we'll also take great care that this functionality works well with the generated TypeScript definitions from Kotlin.js code. Now, while I won't give any concrete ATAs for any of the topics that I covered just now, because I personally happen to believe that doing such things probably just brings bad luck to the release schedule, the awesome news is that these topics are already visible on the horizon, and I'm looking forward to when we can all play with them. To round things out, I want to shout out one more topic, which is certainly even farther in the future. And that topic is Kotlin for WebAssembly. Now, two folks from the Kotlin.js team are now actually a part of the WebAssembly community working group and represent Kotlin there. Another good piece of news is the fact that the working group now already has a proposal for a managed runtime, which includes a garbage collector. And that's something that's essential for a language with a memory model like Kotlin's. Now, I personally hope that we'll be able to see a prototype of Kotlin on WebAssembly soon, but again, no ETAs. Now, of course, I don't want you all leaving this talk with only dreams of the far future without actually giving the technology a try. Because we've seen a lot of stuff today that shows what you can do right now with Kotlin.js. From a number of well-supported libraries, how Kotlin can carve a path from being a library in your JS app to becoming your full front-end application. And we even saw that fast projects and full products can be built with and are built with Kotlin.js. From our plans, I hope it's clear that we continue investing heavily in Kotlin.js, but of course, technology can only succeed if there are people using it and especially giving us feedback. Which is why I implore you, give Kotlin.js a try. It can be a fun technology and just a great way to broaden your horizons and deployment targets while sticking to a language that, judging by the fact that you are listening to this, you probably thoroughly enjoy. To find the latest topics around Kotlin in general, and also Kotlin.js specifically, as always, check out the official Kotlin blog, which you can find on blog.jetbrains.com/Kotlin. You'll find the latest and greatest changes there, information about how to turn on the experimental IR compiler, or how to already see what the TypeScript integration is going to generate for your code. Besides the blog and the official documentation, which you can find on kotlinlang.org, we also have the ever-expanding catalog of long-form tutorials I mentioned before on play.kotlinlang.org. Those are our so-called hands-ons. We kind of already provide materials about that talk about building React applications with Kotlin.js, writing full-stack multi-platform applications with Kotlin.js and Kotlin JVM. And there are a bunch of cool materials on the way as more and more of these cool features we've talked about will become available. And of course, for the libraries that we've spoken about, like serialization, coroutines and Kotlin React, I suggest having a look at their readmes and guides as kind of starting points for your experiments. The same goes for the community libraries that we mentioned in the Spotlight section. Honestly, I could probably keep talking for hours upon hours on these topics, but my time is up. So if you felt that any topic did not get the attention that it deserved, or where you simply want to get some extra information, I'm more than happy to chat. You can always get in touch with me on Twitter or via email. You can scrutinize my side projects and my demo projects on my GitHub account. And you can, of course, also reach out to me on the Kotlin Lang Slack channel. I'm hanging out in the Kotliners Lounge, but you can also ping me directly just under my real name with a JB tag. I'll also be joining the fireside chat this evening if you have any more questions about the topic. Apart from that, I can only say thanks a lot for listening. Have a wonderful Kotliners event and have a nice Kotlin. Yeah.